In these examples, we need to factor these quadratics first, and then we'll do like what we did before where we set each term equal to 0, each factor. So, when we're factoring this trinomial, we need to see what multiplies to 1 times 5, so what multiplies to 5, that adds up to 6, that middle term. Our multiples of 5 are just 1 and 5. 1 plus 5 does give us 6, so our factors are x plus 1 and x plus 5. And all of this is still equal to 0. We're going to keep that equal to 0. And this is where we take each factor and set them equal to 0 individually, and then solve for x in each one. So in the first one, I'm going to subtract 1, so we get x equal to -1. And then in the second one, I'm going to subtract 5, so here x is equal to -5. Those are our two solutions. In number 5, we have a difference of squares. So our first term that we're going to take the square root of, we get 2x. And then our second term, the square root of 25 is 5. So we have 2x minus 5 and 2x plus 5, if you remember your difference of squares rules. And then we can set each one equal to 0. In the first one, I'm going to add 5. So now we have 2x equal to 5, and then divide by 2. X is equal to 5 over 2. In the second one, I'm going to subtract 5, and then divide by 2. And those are our two solutions. In number 6, we can take out a GCF first. So I'm going to factor out a 2. And we're left with x squared, dividing everything by 2, 10x, and 25 equal to 0. Now looking just at my trinomial, I'm going to see what multiplies to 25. That adds up to -10. The factors of 25 are 1 and 25, or 5 and 5. But I need them to multiply to a positive number but add up to negative, which means both numbers would need to be negative. -5 plus -5 is -10. So now we have 2, keeping that 2 from before, and then x minus 5 squared, or you could put x minus 5 equal to 0. Now here, since we have the same term twice, we only need to worry about it one time. So I'm just going to say x minus 5 equal to 0. So then this graph would cross the x-axis at 5.